In this video lecture, I'm going to discuss the electrophilic addition mechanism again, but this time I'm going to discuss the hydration of alkenes, which is the reaction of alkenes with H2O. So it's the reaction of alkenes with H2O. The conditions for this reaction are 300 degrees centigrade is the temperature which is required, 60 atmosphere is the pressure, and phosphoric acid is used as a catalyst. Now I have an alkene over here and it has this double bond, this electron rich center which has a lot of negative charge. And the catalyst is important because it produces this H plus 1, these H plus 1 ions. So these H plus 1 ions are produced by the phosphoric acid catalyst. And these H plus 1 ions are going to get attracted to the negative electrons over here. And remember, the arrows, the curly arrows represent the movement of electrons. So the electrons in this double bond are going to be attracted by the hydrogen over here. So what would eventually happen is that the electrons in a pair of electrons in the double bond, the pi electron cloud to be very specific, that's going to get attracted to the hydrogen ion, positive ion over here. So if the electrons over here get attracted by the hydrogen and the hydrogen ends up bonding with them, the other carbon atom loses the electrons in the double bond and it gets a positive charge. So you have a carbocation intermediate which is formed. So let's write that down. So you have a carbocation intermediate which is formed. And in the next step, what happens is that you have a water molecule which has these lone pairs. Oxygen has these lone pairs, and water is a very polar molecule. It's involved in hydrogen bonding as well. So these lone pairs on oxygen are going to get attracted to this positive carbon over here, and the resulting product is going to be that you're going to get there would be carbon and hydrogen. There's one hydrogen which has already bonded from the acid, and over here what's going to happen is that the water molecule, one of the lone pairs from the water molecule, would be attracted and it would eventually bond with the carbon atom over there. And this oxygen is going to get a positive charge because the lone pairs on oxygen are now with carbon, they're being shared with carbon, so this oxygen gets a positive charge. So in the last step, what happens is that this oxygen wants its electrons back, so it's going to eventually lose this hydrogen. It's going to take those electrons from hydrogen, and this hydrogen is going to break away, and the product that would be formed is going to be, you're going to get this product. You will have CH3 which would be bonded to two hydrogens and an OH group, and the hydrogen ion breaks away. So hydrogen ions are acting as a catalyst. They started the reaction, and at the end the hydrogen ions are reformed. So they're not taking part, they remain unchanged in the reaction, they're taking part in the reaction, they speed up the process. So this mechanism is exactly like the electrophilic addition mechanism that we studied before. So you have your slow step, this is your first step, and after that you get your products, and then the last step the hydrogen ion breaks away.